We have three objectives for today: study the parity of a function, determine the axis of symmetry of the curve of f, identify the center of symmetry of the curve of f. Objective 1: Studying the parity of a function. As we learned last year, functions can be even, odd, or neither. Determining the parity of a function helps us understand its symmetry, which can simply graphing and analyzing the functions. Studying the parity is useful because it provides insight into the function's behavior, making it easier to solve equations, integrate, and understand the general shape of the graph. Even function. A function f is said to be an even if and only if the domain of f is centered at 0. This means that for every x in the domain, minus x is also in the domain. The function satisfies f of minus x. It's equal to f of x for all x in the domain. This property implies that the graph of f has an axis of symmetry along the y-axis, denoted as y prime or y, as shown in the figure. X and minus x have the same image, clearly indicating that the y-axis acts as an axis of symmetry for even function. Let's now solve this example. In this example, they are asking us to prove that f of x equals 3x squared minus 4 is an even function. So we need to verify the following conditions that we stated before. To state that the domain is centered at 0, so we need to calculate the domain, which is in this case it's R since it's a polynomial function, plus we need to prove that f of minus x is equal to f of x for all x belong to R since R is the domain. So let's proceed with the solution and check each of these conditions step by step. Odd functions. A function f is said to be odd if and only if the domain of f is centered at 0. The function satisfies f of minus x is equal to minus f of x for all x in the domain. This property implies that the graph of f has the origin O as a center of symmetry, as shown in the figure. X and minus x have opposite images, indicating that the origin acts as a point of symmetry for odd functions. Let's now see this example. We need to show that f of x is equal to 2x cubed negative 5x is an odd function, so we only need to prove these two conditions as you can see here in the solution. Objective 2: Axis of symmetry. Last year we studied different elements of symmetry, including the axis of symmetry. Let's recall this concept. Axis of symmetry. Consider the vertical line x equal a. To prove that x equal a is an axis of symmetry to the curve of f, we need to prove two things. The domain of f is centered at a, and f of 2a minus x is equal to f of x for all x belong to the domain. For example, let's consider this function f of x equal x squared negative 2x plus 5. We need to verify that the line D of equation x equal 1, so in this exercise a is equal to 1, is an axis of symmetry to the curve of f. So here, of course, we need to prove that the domain of f is centered at 1, and don't forget that the real numbers set is centered at any number you want. Then we need to prove that f of 2 multiplied with 1 minus x, so f of 2 minus x is equal to f of x. Objective 3: Center of symmetry. The second element of symmetry we studied last year is the center of symmetry. Let's recall its conditions. Center of symmetry. Consider the point I of coordinates AB. To prove that I is the center of symmetry, we need to prove these two conditions. That the domain of f is centered at A, which is the abscissa of this point, and also we need to prove that f of 2A plus f of x, it's equal to 2b. Consider the following example. We need to prove that the point I of coordinates 3, 4, the center of symmetry of the curve of f, which is equal to x plus 1 plus 2 over x minus 3. And simply we only need to prove these two conditions, as you can see here in the solution.